So there's a picture at the bottom of your screen. It's got like it's got like a masses on two sides of a point, like a kind of like a seesaw, but it's not exactly that.
Okay.
Let me get to where I can get a reference up. See if I got the ones up from last night. I do. Great. That will make this a whole lot faster. Okay. So you've got a picture here. Let me see if I can just snip this right on top. Yeah, so you got that's the picture you're seeing at the bottom here. They want the magnitude of the net torque, and so on and so on. So the magnitude of the net torque, there's two torques here that are happening. So you've got, if you look at this point right here, one of the masses causes it to go counterclockwise, and the other one causes it to go clockwise. So there's they call it torque net. Basically, this one produces a torque this way, going this direction. The other one produces a torque going this direction, and you have to calculate those two together. So torque is force times distance. The force on both of these is mg, and the distance is L1 and L2. So they use they make counterclockwise. Yeah, they make counterclockwise positive. You can choose whatever direction you want to be positive. So this one on the left is positive, so it's mg. This one on the left times L1, and then clockwise is negative. So that's minus mg L2. And this is your answer for part one. You can do L1 minus L2 there.
Alrighty, let me get these down. Minus mg L2. Be sure to use all given information to derive a positive expression for the magnitude of the net torque. What does that even mean?
Are you saying what we get, what I provided you is not correct?
Yeah.
Well, what's interesting is I'm looking at exactly the question you have here, and it is exactly what I just wrote there.
Wait, never mind. I think I did it.
Oh, the magnitude. So they want you to, because they choose the other direction as positive. So in their world, it's L2 minus L1.
Oh, L2 minus L1.
Yeah.
Right.
And they're saying, well, that's because more torque is being produced by L2 because it's further away.
Mm-hmm. Is it going to go counterclockwise?
Clockwise.
Clockwise, all right.
Because this one on the right's bigger, so it's gonna bend more, and that's obviously clockwise if it's going down.
All right. Did I send you introduction? Wait, I probably didn't. Let me screenshot these and send them to you.
I got let's see what else I got. I got 8.07. I guess we've already done that.
Yeah, this next one is kind of interesting. Kinetic. All right, kinetic energy with inertia, and then some introduction to inertia. I'll send you these screenshots right now because I just got them. Attach, please. Pretty nice of you to attach these. Nope, that's not what I wanted. There we go. Attach file. And there we go.
Okay, I see that you've got some more problems that have come through here. We got Chapter 8, Kinetic Energy with Moment of Inertia. Is that right? They've got a couple other questions here. Maybe you're muted. All right. Consider a particle of mass m equals 13 kilograms revolving around an axis with an angular speed w. The perpendicular distance from the particle to the axis r equals 1.75 meters. They give you a picture. Which of the following are units for expressing rotational velocity? Radians per second is a common one. Revolutions per second is a common one. The degrees per second I'm not sure of, so I can check here before you submit if you'd like. I gotta look it up anyway because the rest of the problem I won't be much help.
I'm gonna go get a drink of water real fast.
Okay.
All right, I'm back.
I'm not finding anything. So I guess I would tell you to go with the first two. If that doesn't work, add in degrees per second.
That's correct.
Okay. Okay. So the kinetic energy is part B. Is that right?
Yeah.
Kinetic energy is 1/2 IW squared. I believe IW squared.
Assume omega is 18.0 radians per second. What's the magnitude v of the velocity of the particle in meters per second?
Yeah, so I'm not seeing a reference here. There's a good one. Okay, so the kinetic energy is 1/2 IW squared. So this is a known thing. I takes on different values depending on the problem. For this one, they suggest mr squared. I depends on the geometry of the solid. There's different geometries like a sphere, cylinder, a thin hollow sphere, hollow cylinder, so on and so on.
Yeah.
So you substitute that in, you get mr squared w squared, and sometimes you rewrite w as something over something, but they give you w in this problem, right? They tell you w is what value?
18.0 radians per second.
Where did they give that?
They give that in B.
In part B?
Mm-hmm.
Oh, you have to complete part B. I see.
Yeah.
Okay, I'm like, where is that? Okay, so we have 1/2. Your mass is 13. Your R is 1.75 squared. Your W is 18 squared. So go ahead and calculate that, and that'll be your energy in joules.
All right.
Wait,
Type the
what
number.
is part B asking for?
It's asking for magnitude and of the velocity of the particle.
So what I just did is part C.
Oh, okay.
Part B is RW.
Yeah.
The radius is 1.75, W is 18. That's all it is for part B.
Just 1.75 times 8?
Yep, 18. 1.75 times 18. R is 1.75. You said omega is 18.
Mm-hmm.
That's V. And that's in meters per second.
31.5 meters per second for this one. Correct. All right, time for part C. And I get like 600 and 644. Wait, no, 6449.625.
Okay, that's reasonable. I don't know how many how many significant figures, but
It says correct.
okay. Part
D.
D. So I don't have part D. Let me see if one of these references has a part D in it. No. Does that ask for the moment of inertia?
Moment. Yeah, it does.
Well, the moment of inertia in part D, which we already have here, it's I equals mr squared. So it's 13 times 1.75 squared.
Awesome. $39.8125. That's correct. All right. Let's go on to number 11, Introduction to Moments of Inertia and Kinetic Energy.
Okay. Wow. Boy, there's a lot here. Just getting to where I can snip this in. So coming in now. We was successfully updated. Okay. Earning gold to understand. Okay, so I'm not finding these. So they never, these references never give for the first one. So the moment of inertia definitely depends on the shape and density of the object. Total mass and location of the axis of rotation. These are because I is equal to mr squared. That's the mass. This I changes based on that, and an R is based on the location of the axis. W is equal to V over R, I believe, or V times, was it V times R? That's V over R, I think. So that's not linear. It might be linear speed. I don't know. I would try those three first, I guess.
Those are correct.
Okay. All right. Part B. I have to go back to the email. Part B. What is the moment inertia IA of particle A? Okay, so notice particle A is 3r away.
Mm-hmm.
I equals mr r squared, but r in this case is really 3r. So I equals m 3r squared, which is 9 r squared, or 9 mr squared, which is letter B there.
Can you repeat that one more time?
Letter B, 9 mr squared, 9 mr squared. Looks like it's letter B.
Oh, is it 9 m squared?
Say that again.
Says it's incorrect. The moment of inertia the moment of inertia doesn't depend on the mass alone. Please review the comment that followed part A. It said, unlike mass, the moment of inertia depends not only on the amount of matter in an object, but also the distribution of mass in space. The moment of inertia is also dependent on the axis of rotation. The same object rotating with the same angular speed may have different kinetic energy depending on the axis.
So it's probably undefined because an axis rotation has not been specified.
You're correct.
Part C is asking for around the x-axis.
Mm-hmm.
So it's like mr squared is probably it.
That is correct.
Part D is if it's around the y-axis. Then if that's the case, that's what that calculation I just did. You probably will have to start sending me screenshots of this, unless is part. Or
Yeah,
are you up to part?
I can send screenshots for you.
Okay,
I'm on part C right now. What did I put for part C again?
Part C might just be mr squared because it's just asking for the moment of inertia around the x-axis.
Oh, okay. That's correct. All right, find the moment of inertia of a particle with respect to the y-axis.
So that's this m3r parentheses squared. So it's 9, and that becomes 9r, 9 mr squared.
9 mr squared. Correct. Part E. Find the total moment of inertia of the system of two particles shown in the diagram with respect to the y-axis.
Yeah, I really probably need a picture at this point. Is it one at a time?
Yeah, it does. I don't understand why it would do it one at a time, because I need to, look at the whole thing. But whatever. I got the screenshot. I'm attaching it right now. There we go.
Okay, I see it's come in. Find the total moment of inertia of the two particles shown in the diagram with respect to the y-axis. Okay, so with respect to the y-axis, you got 1/2 m, and then letter A is 3r away squared, and letter B is just m away. Oh no, these are just m. Sorry, these are just m, not those are not 1/2. So mf and r squared. So this is for point A. It's 3r away. This is for point B. It's 1r away from the y-axis. So that's 9mr squared plus 1mr squared. So it looks like it's 10mr squared for that.
Sounds good. 10mr squared. (10mr squared). That wasn't correct. Your answer either contains an incorrect numerical multiplier or is missing one. 10mr squared. That's why I put in there.
maybe, yeah, I have no idea why that isn't working. I'll look for a few more. Some of these did have, I guess, part E in it. Let me see if I can find it. That one did not. So this one is I2 is, oh, so something about the second ball is that it has double the mass. Do you see that somewhere?
Say it one more time.
Does ball B have double the mass?
Ball B. Let me see.
Meaning like I'm asking, is that written somewhere? Because I don't see that.
It doesn't say double the mask.
The one that I'm looking at here suggests that is the case.
Oh, it is?
And so what that does is it changes, this M becomes really 2M, that's really 2M. So they
Because
get 11. Now, are they asking about kinetic energy, or are they asking about
that's correct, 11 mr squared.
Yeah, okay. I don't know where that came from.
They kind of pull it out of left field.
Yeah.
Let me get this screenshot, sending it to you as fast as I can. Reply, attach, and the screenshot 59. There we go. There we go.
Okay, so the kinetic energy is 1/2 I W squared. And we just found I is 11 mr squared. So it's 1/2 times 11 mr squared W squared. And we have everything. So I think you can just write 11 over 2 mr squared W squared. Those are the 3 allowable variables.
Sounds good. It's odd. It wants this weird. Ah, there it is. All right. This W for omega. Then we can do square this up. What? Different numerical multiplier again, I think. Wait, no, never mind. There we go. 11 divided by 2. There we go. All right. Oh, they showed 2 this time. Very bold of them. I'll send the screenshot. Can you hear me while I'm talking?
Yes.
All right.
I'm just standing by here waiting for the next one to come in.
It's a real pain the way that they do it. There we go.
Let's see.
There we go. Should send in quickly.
Okay. All right, there it is. Okay, part G. It says 1/2 mv squared. Find the kinetic energy of particle A. Particle A.
Very layered.
Well, the I wonder. Yeah, I'm not sure. I mean, we might set this equal to the uh, uh, energy from one of the previous parts, but I don't know. See if I can get this in here. So it does say V equals RW, which we know that. So kinetic energy is 1/2 mv squared, and we know that V equals RW. Can it be that simple? So, and then R of A is really 3R.
Mm-hmm.
So it's 1/2 m, and then instead of R, it's 3RW squared. So that gives you a 9. So it gives you a 9/2 m R squared W squared. I guess I would give that one a try.
MR squared squared W squared. Correct.
Okay, for part H, the kinetic energy, it's the same thing. It's 1/2 m V squared. V equals RW. This time, though, R is just 1 unit. It's right there. But M was 2m. I remember that from a previous problem. So it's 1/2 2m, and then RW squared. So the m's, so you get M R squared W squared. Looks like it might work for that.
R squared W squared. Correct. All right.
I did see a part I in one of these pictures that I was looking at previously for
Sending it right now.
total
There we go.
kinetic energy. So you just add them together. So you get your 9/2 m R squared W squared plus 2/2 m R squared W squared. I just wrote that instead of 1, 2 over, so it's 11/2 m R squared W squared.
Oh, so 11/2 R squared W squared. Wait,
Yeah.
MR squared W squared.
Yes.
MR squared omega squared.
Yes.
I'm gonna get that in there. This should be it. Correct. All right. I'm gonna send you a little bit of some math homework.
Okay. I will stand by here waiting.
Sent it.
Okay, let's see if that's come in. All right, it is here. Okay, so amplitude and period for sine and cosine, is that correct?
Yes, that's correct.
All right, do you need to do all of them or just certain ones?
Let me check that real fast. Oh, you don't have to write any equations for him. Just skip it. All right.
Okay, so just go through them all. Is that
Yeah, just go through as many as we can.
okay? So the you have to know the parent function here. The parent function is y equals a sine bx, and this is a reduced form of this. So the amplitude is always the absolute value of a, or it's the absolute value of the number that's in front here, which is a 1. So it's the absolute value of 1, which is 1. The period, so it depends on which trig function you're going with. If you've got a sine or a cosine, which is what you have here, for sine or cosine, your period is always 2 pi over b. Well, what's b? B is the number in front of x. It's 2 pi over 4, which equals pi over 2.
Oh, okay.
All right, snipping in number 2.
Oh, so these are pretty straightforward.
Yeah, they're very repetitive.
How relevant is the wait? Never mind. I'll see
So,
on the next
so
one.
the amplitude is going to be the absolute value of the number in front, which is 1, which equals 1. The period is 2 pi over the number in front of x, which is 5, and it doesn't reduce
To
for
anything?
that.
Sorry, on the periodic. No, not the. I almost said periodic table. On the unit circle, right?
It doesn't necessarily have to. So I'll just start writing the answers so you can see the amplitude for number 3 is 1, and the period is 2 pi over 1, which is 2 pi.
Yes.
For number 4, the amplitude is 4, and the period is 2 pi over 1, which is 2 pi. For number 5, the amplitude is the absolute value of -2, which is 2, and the period is 2 pi over 1.
Which is
6 is sort
simplified.
of 6 is sort of an oddity. The period is not negative, so the let's get to that. Amplitude is the absolute value of 2, which is 2. The
Correct.
period you would think is 2 pi over -4. It's that negative can be dealt with in a different way. I don't think it should be in here. It's not the absolute value though, but period is always positive. So that's just a, I don't know, side note there. 7 has an amplitude of 3. And the period this time, this one you have to do a little bit simplification, is 2 pi over 2/3. You reduce this by multiplying by 3/2, top and bottom. So it ends up being 3 pi is the period. Okay. Do you want to, do you good with 8 and 9?
I think I'm good with 8 and 9.
Okay.
Yeah.
All right, let's look at 10. that snipped in here. Okay, so the amplitude, this is where you need a little bit more information than just a formula. You have to know where the center line of this thing is. So the center line is is there, right there at 0. So the
Yeah.
amplitude is how far up it goes or how far down it goes, either one.
Yeah.
So in this case, it's 3.
Mm-hmm.
But it's from the center line, which just happens to be the x-axis. To find the period, you need to know peak to peak. How far is it from peak to peak? And this one does a terrible job of showing that. I guess this is pi over 2,
Mm-hmm.
and this is 3 pi over 2, although it's really unclear. And then you do a right minus left for that. This is complete. I mean, this is not. I mean, I I can't tell where these values are. Is that maybe that's not right? That's maybe pi is there. This is really messed up. This has been copied or
Copy pasted to death or something.
they don't mark. So that's 0. Okay. So the other way to do this is let's just say this is minus pi, and it probably is. You want to get back to where you started. See how it's on the way up here, and this is
Yeah.
on the way up here. So that's start to start, and that's obviously 0. So 0 minus a minus pi gives you pi, and that's the period.
Mm-hmm.
Now this is much harder to do. There's two equations. There's y equals a sine bx, and then there's y equals a cosine bx. And you have to know what does a sine look like? A sine generally starts at 0 and goes up and down like that, but a cosine starts high and goes low. This one starts at 0 and goes up, so it's definitely a sine.
Yeah.
Okay, now since it goes up, it's a positive number. You put the amplitude out front,
Mm-hmm.
and then you need to get this b value. So the b value comes from the period. So the period equals 2 pi over b, which we used in the previous problem. But b, when you solve for b, is 2 pi over the period. I'm sorry, the period. I put the period in there. 2 pi over the period. So in your problem, it's 2 pi over
Just straight up
pi,
pi. All right.
which equals 2. So you put a 2x there.
Oh, okay. Makes sense.
We're going to do 12 next because it's more related to 10 than the others.
Okay.
Okay, so this one will be a little bit more clear. The amplitude is the center line, and then how far up does it go from the center line? What say you?
How far does it go out from the center line?
Yeah,
It goes up 2, right?
2. So amplitude is 2. It's always a positive number. The period, you could go peak to peak, but let's go where you start and then all the way back to where you start. So to go all the way back where you start, how far is that?
That's 4 to the right, and then all
4
the way.
pi
Yeah, 4 pi. Okay.
minus 0. So it's 4 pi. It's 4 pi minus 0 equals 4 pi. So we mentioned this before. It's a sine because it goes up.
Yes.
So it's y equals, and then you need the amplitude, 2 sine, and then to get the b value, period equals 2 pi over b, so b equals 2 pi over the period. 2 pi over 4 pi, which equals 1/2. So this is 1/2 x.
Oh, okay.
Whatever that b value is, it comes back here. Okay, now we're going to do 11 and 13. They're more of they're cosines, so we'll see what's different about those. All right, so the amplitude is from the origin up to here. The amplitude is 4. The period is, again, you could do this thing where you go back to where you started. You could also go like peak to peak,
Yeah.
which is kind of the same thing, valley to, or you can go valley to valley. Here it's 2 pi, so it's 2 pi minus 0 equals 2 pi. So this time it's a cosine because cosine starts high and goes low. So it's y equals 4 cosine. And then we need the b value. So the period is 2 pi over b. So b is equal to 2 pi over the period. 2 pi over 2 pi equals 1. So it's 1x there. All right, 13. Okay, so now how far up does this go?
I go all the way up to 5?
5, yep. So the amplitude is 5. The period is still peak to peak. So you can do this right minus left. So your right is here at
Oh, is that
pi.
what that is? Okay.
Yeah, and your left is at minus pi. So that equals
2
2
pi?
pi.
Oh,
So your equation is y equals, now it's normally the amplitude, but see how it starts, cosine usually starts high and goes low. Well, this one starts low and goes high.
okay.
That's a negative in front. The negative was what causes it to start down there. Cosine, and then it's b. So 2 pi period equals 2 pi over b. B equals 2 pi over the period. So it's 2 pi over 2 pi, which is 1. So it's cosine 1x there.
Sounds good.
All right, let's continue here. Those last 4 are graphing. You're going to have to do these by hand, but you should definitely consider just going Desmos and graphing these to see what
See what they make up.
see what they look like. It's not, I mean, it's not the best way to learn, but it's really visual. It's, if you're a visual person, you like to see things, you know, what better way than that? So a couple of these things we can do without graphing it. So the amplitude is this number in front, the absolute value of that number, which is 3. The period is 2 pi over the number in front of x, which is 1. So it's 2 pi.
All right.
Now, the way that I show people to graph this is very different than the way they show you in the classroom. But you can use whatever method you like. So you go out one period, and then you go half a period, put dots, and then you go at the midway point between each of those. All right, and then what I like to do is I like to draw a sine curve that the basic sine curve with the period. Now, what I've graphed here, this is the sine of x.
Oh,
So the next thing I'm going to do here is I'm going to grab a different color, and now I'm going to put a 3 in front. So what does the 3 do? Well, it pulls up any point that's 0, it stays the same. But if it's 1, it goes up to 3. And if it's -1, it goes down to -3. So now see how this pulls it?
yeah, I do.
All right, now this is always this issue of like, well, how much do I have to graph? And I would actually tell you just to keep going to the right, but your instructors could want you to go backwards, and you just have to map this. Like it has to look exactly the same
Oh,
going in there. So that it's a little bit, you know, you go out -2 pi, pi, and pi over 2, 3 pi over 2, and you just kind of go backwards here where you get these values, and it's the exact same graph like that.
oh, okay. I see what you mean.
It's copied over the periods there. Okay, we're gonna do 16 because it's another sine. That's usually a good one. It's usually good to do them in groups like that. Okay, we got all right, so the amplitude this time is 3. So the absolute value of 3. The period this time is 2 pi over 2, which is pi.
Mm-hmm.
All right, so now again, this is the way that I do it. You go out one period, so you go out to pi.
Yeah.
Then you cut it in half, which is pi over 2, and then you find the other one and the other one. And there's 5 points you have to grab. 0, 0, you go up, back down, down, and then back up. So this is what your regular sine curve looks like. That's sine of 2x because you've taken into account the period.
Understandable.
You follow that?
I do.
So now we have to take into account the period. So the only, or I'm sorry, the amplitude. So again, the only thing that does is it stretches points. That 3 is going to pull it up. Anything that was at 0 stays the same, but 1 is going to go up to 3. -1 is going to go down to -3, and it looks something like that. Okay, and then the question is, well, how much more do you graph? So a lot of times they say, I think these instructions say to go out like -2 pi to 2 pi. Sometimes they say 2 periods on your, and that means you have to repeat the image twice if it's 2 periods. So then, but you can, and it's easy though to get off. So you almost have to just restart everything again. So it's that point, and that point, and you'll see it comes up and down, and then we have to do the same thing over here. So it comes up like that. It's just really awkward to draw on the left side here. Looks something like that. All right, so we are really close to being out of time here. I would just recommend using Desmos for the other two.
Mm-hmm.
You'll see what they look like, and you'll probably have it pretty quickly. Probably take you less than 5 or 10 minutes to do, if that.
I always appreciate your time, Matthew.
You're welcome. Thanks for scheduling, Jack. I'll send this notes and our screen recording out later today.
Thank you.
Okay, bye now.
Bye-bye.